Hello student, welcome back to our YouTube channel. So today we are going to see array implementations of a stack. Here the declaration of a stack array is the name of the array. In future we will have functions for a different operation including push and pop. Almost every functions require the stack array. Instead of passing it every functions, the better option is to declare the stack array globally. Here the declaration of a stack array. Here int stack is declared. Int stack array 4 is the global declaration of a stack array. And here we have to declare the value which is a max, like define max 4. So here we define max 4, so we don't have here to declare 4. So first we have to declare that define max 4, and next int stack array. Here we declare max, in which it defines max 4. In certainly int stack array is contain 4 elements. So declaration of a top stack array 0, 1, 2, 3 and 1 is the top. Similarly, top variable is also multiple times in a different function. Instead of passing it to every function, the better option is to declare the top variable globally. So first then int stack array max and int top is equal to -1. Top is equal to -1 because this in the stack we have to declare top, and here we declare top is globally. Top is equal to -1 indicates that the stack is empty, and here in the int main functions we are interested to pushing the element 1 onto the stack. So here we write push 1, and then pushing an elements involves two steps. Increment the variable top by 1, store the value at the index tops, in which this is the push operations. So we write void push int data. In data is the here 1 is the data, and 1 is we have to push 1 in the array. So next top is equal to top plus 1. When we have insert data in a stack, we have to increment top by 1. So top is equal to -1, and then top is equal to top plus 1, and next top is equal to -1. 1 by 1 top is equal to 0. So index 0 we insert the element stack array equal to top data, and then give the data values for top. Here the insertion of a stack array, and next also two data is inserted, and next two data is inserted here in a stack array 2, and then next 3 and 4. Here the array is full. So when it is important to check whether the stack is full in the push operation for insertion. So here we declare int top is equal to max -1. Max is equal to 4 as we know, and then the condition if top is equal to max -1, then the stack is overflow and return null. And then the pop operation. Pop means delete operations. Data is equal to pop int value equal to stack array top equal to top -1, and return the value. Here we want to delete the value 4, so we delete the data. And next also the condition is here when the stack is empty, so we have to declare stack is empty. So here the function if top is equal to -1, Then printf stack underflow and exist1. Exist1 means abnormal terminations of the programs. Value is equal to stack arr top. Top equal to top minus 1 and return value. Here the code for the int main. Here we declare choice and data, while 1/n means a default line. Here the menu push, pop, print all the elements of the stack and quit. Please, and then we have to we declare the input that please enter your choice. Scan %it @choice. Switch choice. Case 1. We declare case 1. In case 1, we call the function push, in which printf enter the element to be pushed and the scan %d data. Then push the data elements and then break. Here the here the cases for the operations: push, delete, push, pop, and the next topmost elements of the stack, in which it means pick, and then break and exist. So next is a queue. Introduction of the queue. Queue is a linear data structure in which the operations are performed based on a LIFO first in first out principle. In a queue, always the insertion operation is done at the rear and deletion operation is done at front. In a queue, sequence of the elements entered into the queue is the same as the sequence of the elements leave the queue. Next, queue. Queue definition of the queue. Queue is a linear data structure in which the operations are performed based on a FIFO first in first out principle. The queues field are rear, front, size element, in which rear is used to store the position of insertion. A front is used to store the position of a deletion. Size used to store the size of the queue, and same as element is used to store the value to be inserted. Next, the queue's functions. Here the three functions of a queue: enqueue, dequeue, and display. Enqueue means to insert into the queue. Enqueue means insertion. Insert the element into the queue. Dequeue means delete an element from queue. And display. Display means, as all we know, display, it will display all the element in a queue. And the condition: rear is less than, rear is greater than or equal to size minus queue. Size there are the two conditions of a queue: rear and front. Rear is greater than or equal to size, then the condition is a queue is a full. And next, front equal to rear. This is the condition in which queue is empty. So implementations of a queue hash define, as we know the code. So you can see here we declare a define size 4 in queue size. Front equal to -1, rear equal to -1. OP is the options, and element is the which element to be inserted. Here we declare three functions: wide, enqueue, dequeue, and display. And to simply select, this is the menu. Select your options: insert, delete, and display. And this is the switch operations. When we insert one, the case 1 is a run. So in a case 1, enter the element to be insert and %d element. And here the element is a pass as arguments in the NQ operations. So first, when we compile the executes above the code, it allocates memory as follows. Like here the Q is a here the elements indices 0, 1, 2, 3 up to size minus n. F means front, R is equal to rear, F equal to R equal to minus 1. Then front rear. F equal to R equal to minus 1. Then the condition is Q is empty. Insertion. Insertion operations. NQ int element. If rear is not equal to size minus 1, then rear plus plus means rear increment, and Q rear is equal to element. And else print Q is a full. Here the insertion elements. When the NQ10 is performed, it will be rear plus 1, and then 10 is inserted as a rear values. Similarly for 20, 30, 40, and then the Q is a full for the rear value. So deletion. DQ. If front is not equal to rear, front plus plus, elements remove and display the elements which remove. And else print F Q is empty. DQ, it will delete the front elements, and then front plus plus, and also delete the front element. When we call the DQ functions 4 times, all the elements are removed, and next 5th time when we DQ function is called, it will say the Q is empty. Then this. So display functions. If front is not equal to rear, for int I equal to front plus 1, and I is a less than or equal to rear, and increment I by 1. Then the print elements in a queue, and else the queue is empty. Display. This is the display element of stack of a queue. You can see here where enter we call one option which is insertion. Enter element 40. 40 is added 30, 20 and 10, and the next display the queue. Here we call the display function 3, and in which the display the elements of the queue. So thank you for watching this video, and don't forget to subscribe my YouTube channel Study with Coder, and subscribe for more videos. Thank you.